Hello and welcome to EMQX's monthly webinar, MQTT and Clean Energy Annual Wrap-Up. I'm your host, Ernest Russell, a Technical Content Manager for EMQ. And today I'm joined by Brandon Ruiz, who is our Product Marketing Manager. And today's goal is we want to wrap up some of the lessons we learned this year in the clean energy sector. So we'll cover first what is clean energy and why clean energy. We'll address some of the challenges in implementing clean energy solutions. We'll give you an introduction to the MQTT protocol and talk about why MQTT for distributed energy resources. And then we'll talk about some specific success stories and examples of customers we've had that have implemented these solutions in the clean energy sector, and including smart grids and EV charging. So Brandon, can you get us started with what is clean energy?
Yeah, absolutely. Thank you, Ernest, and thank you all for joining us either live or on demand. We appreciate your time. So starting off with what is clean energy, right? And simply put, clean energy is all about harnessing power from renewable natural resources, right? So think of it as an eco-friendly way to meet our growing energy needs. And there are a number of ways in which you can do this. The four that are the front runners, as you can see, are solar energy, which captures sunlight with solar panels, ultimately leveraging the sun's endless energy. Wind energy, which is utilizing wind turbines, which you'll see distributed, on rural areas, mountainsides, or even on shorelines to convert air movement into power. So again, harnessing the wind's natural force. Hydropower, which generates electricity from water in motion. So this is really speaking to rivers and streams, or dams for that matter, to leverage the power of flowing water. Geothermal energy draws from the Earth's internal heat. And ultimately, what we're doing with that is tapping into the planet's underground warmth. So all of which are leveraging the natural resources today. So now that we have an understanding of what clean energy is, let's talk a little bit about why it's important and why it's folks are looking to it as a game-changing initiative. So for starters, it's a major player in reducing greenhouse gas emissions. We're tapping into clean energy sources, like I mentioned before, to significantly cut down on pollutants and things that contribute to climate change, which we know is a growing problem. Clean energy is all about smartly using what nature has generously given us. So these are the renewable sources that are abundant and sustainable, and meaning that we're not exhausting finite resources like we would with fossil fuels. So by choosing renewables, we're really thinking ahead of the curve here, and we're ensuring that we not only have energy for us, also for the future generations. So the push for clean energy is really driving incredible technological advancements too. So sparking a lot of breakthroughs on how we store energy, manage our power grids, and improve overall efficiency. So if you think about it, it's really a win-win, right? We get a cleaner and cleaner energy, and we also encourage the development of technologies that are more efficient and cost-effective. Next slide, please, Ernest. So now that we have an understanding of what clean energy is, why it's important, do you want to cover some of the major challenges within the space? So while clean energy is a game changer, as I mentioned before, it's not without its hurdles, right? And here are some of the main challenges in implementing clean energy and how IoT, particularly with MQTT, can play a big role in overcoming them. So first off, we have the challenge of variability. So renewable sources like solar and wind, they're amazing, but they depend a lot on the weather, which isn't always, predictable. So this can ultimately lead to an inconsistent energy supply. But here's where IoT really comes in. It can help balance and predict these variations, ensuring more reliable flow of energy through sensors and being able to log different patterns. Then there's the ongoing need for research and development to take energy more efficient and cost effective. So continuous innovation here is really key. So IoT technologies here again can play a very crucial role in offering us more efficient, streamlined ways to enhance clean energy solutions. I skipped over this one, sorry. For grid integration, also adapting our existing energy grids to embrace clean energy. It's really a complex and challenging task. A lot of these devices were deployed or systems were deployed many years ago. So it's not just about plugging in new sources. It really involves smart tech and significant infrastructure upgrades, right? And IoT with its smart grid capabilities can make this transition more smooth and more efficient. And lastly, here we also have interoperability, and this is also an extension of those legacy devices that I mentioned and the various different sensors and control modules that are out there. So this is where MQTT, which as we know is an open and standardized protocol, becomes a significant feat in this area. So it allows different clean energy devices and systems to communicate more seamlessly. So you're more or less creating that unified and interconnected clean energy ecosystem, right? And essentially, simply put, it's like teaching all of our clean energy solutions to speak the same language, enhancing things like coordination and efficiency. And there are a number of ways that you can do this. You can do translation at the edge or device level, or you can do it at the cloud level as well. So to recap, while the road to widespread adoption has its challenges, IoT and protocols like MQTT, they can be seen as crucial allies that will drastically help navigate and get around and improve these challenges. Next slide, please, Ernest. So with all of the information that we have about clean energy, the challenges, why it's important, right? Want to give you a quick overview of what MQTT is as a standard. Please note, this is not an in-depth coverage of this. We also do have other webinars and materials that really take this a level deeper. But at a high level, MQTT was originally developed by IBM in the 1990s. Once stood for message queuing telemetry transport. Today, it's just the acronym. They've kind of done away with that. But at its core, very lightweight publish subscribe messaging protocol with an incredibly small code footprint, just about 2 bytes. That was really optimized for efficiency, meaning it doesn't consume a lot of hardware resources such as processing power, energy, memory, and can run pretty stably in remote or high traffic areas that are really known to struggle with things like low bandwidth or unstable networks, network switching, those types of things. And it's important to note, especially for this context, MQTT was originally designed to be deployed in oil and gas industry. So similar to how those devices are distributed in rural areas, a lot of what we see in clean energy have a similar environment. So as a proof point for its efficiency, that's what it was designed for. And it also helps bring down cost. So now that you have a better understanding of what MQTT is at a high level, what are some of the main advantages that are in data communication? So there's quite a few. The 3 we'll focus on. Number 1 is it's incredibly reliable. It provides 3 different levels of quality of service, or QoS. Session awareness through persistent connections. So mechanisms like keep alive, last will and testament, and also retained messages. So if, let's say, you're a new subscriber and you're joining, a new subscriber to a topic, you won't be joining and just be left high and dry. You will be presented with the last data point that was generated, so you get something right away. And all of which will help ensure message delivery, right, in the most challenging of conditions, like I mentioned earlier. So all of this makes it well suited for IoT applications, both distributed or very condensed, that are where bandwidth is a concern. So moving on, it's well equipped for large scale IoT deployments as well. So given that it's a publish subscribe model, it really decouples that direct connection between senders and receivers that you traditionally see in IoT. So stands as the broker for traffic between the cloud and the device. And ultimately, what this does is it's reducing things like network traffic and resource utilization, right, which are really important here. And it really ensures message delivery. QoS, as I mentioned, enables you also to customize the message delivery based on your application requirements, which will further optimize your device's performance. And lastly, the other thing I want to cover here, like I said, there's many more, but these are the three we're focusing on. Broad support for various programming languages. So this is really important when you're dealing with diverse IoT ecosystems. So when you're looking at clean energy, whether you're looking at windmill or solar farms, there are a lot of different devices in those ecosystems. So being able to tie into those things seamlessly, this ultimately simplifies the integration process between those different devices in that platform. And as I mentioned before, we do have quite a bit of information on this. So we strongly recommend you to take a look at our MQTT client programming blog series. And you'll be able to learn things about, MQTT in different languages and a lot more. So really recommend you take a look at that. And in closing here, what is the relevance to clean energy as a whole? And I did touch on some of these already, but clean energy installations are often located in remote or harsh environments. So, it could be in mountainsides and very distributed remote areas. So back to that oil and gas example, right? This is the bread and butter of the protocol itself. So being able to give you real-time data transmission in these different harsh environments, incredibly important. Within this space, there's high criticality among these industrial clean energy machines. So reverting back to solar wind farms, dams, power plants, very large machines and systems, false or untimely readings could result in very costly catastrophic failures that can impact not only the grid, but those in the environment within its proximity and nearby, right? So something that really need to take seriously and need to be able to get that real-time data transmission, not near real time. So the last one I want to touch on is the number of concurrent connections. So within these assortment of devices and protocols, across large distributed areas, we're able to support up to 100 million concurrent connections, which we realize is probably a lot more than most people will need in most instances, but we thought it important to really stay ahead of the curve, provide that additional headroom, and to be able to meet your growth needs. So those are the three areas of why we think it's particularly relevant to the clean energy space. And with that, I would like to hand things back over to Ernest.
Thank you, Brandon. So far, we talked about what is clean energy, what some of the initiatives in clean energy. We talked about MQTT, gave you that introduction. As Brandon mentioned, our team has been wonderful with providing blog content, providing tutorials on our website. So a lot of the integrations, the migrations that you need to do, we do have step-by-step tutorials. So everything from just getting familiar with the MQTT protocol itself, or actually getting into the act of integration. We can help with both. So make sure you check out our website also. So why MQTT for clean energy and for managing distributed energy resources? As Brandon mentioned, the MQTT protocol is really efficient and timely. So real-time data communications gives you several advantages, especially when monitoring remote resources. And let me explain what we mean by real time. By real time, we mean sub-second latency. So you're able to send and receive messages in milliseconds, not seconds. And so this translates into real-time monitoring and real-time two-way communication between your devices. Also, with with MQTT, there's an event-driven architecture, right? Where something happens and you're able to trigger something else based on different alarms, right? So in clean energy, there's a huge benefit from this for being able to respond in real time. Let's think about it, especially when you have a machine, a resource, whether it's a solar panel or a wind turbine in a remote area. Usually, there's no one there to monitor when something goes wrong. If there's a malfunction, if that equipment stops, there's some time that goes by, and as Brandon mentioned, that time can be catastrophic as far as loss inefficiency. And so that's one of the efficiencies that MQTT brings us. Another is the efficiency, right? So by minimizing the amount of data exchanged between the two devices, we're able to remotely monitor devices with less bandwidth. So that reduced data transmission overhead helps make the communication more efficient and conserve even more energy. There's the interoperability, right? So this is very important. In the clean energy sector, if we think about how many different manufacturers, how much different types of equipment is involved in these clean energy workflows. So how do we consolidate that communication from different protocols, maybe even proprietary communication on the device level? How do we consolidate that and provide that remote capability? And that's where MQTT comes in. So not just the monitoring, but because we have two-way communication, we also have the ability to remote control and remote configure devices, right? So again, this is a very effective method when we talk about predictive maintenance, when we talk about cutting down the response time from fault detection to action and to repair. Then, so we talked about the interoperability. Then there is the integration with cloud services. And I'll talk about this a little bit more later in the presentation, but many of our existing services for enterprises, our back-end services, our big data services, our AI services, our artificial intelligence services, they're running in the cloud. So it's important not just to make this data available in real time, but available in the cloud, available in your cloud. So the first example that I want to talk about here, and when we talk about clean energy solutions, I'll give you a real life example of this from one of our recent customers. But with MQTT, it's easy to we provide that method to be able to connect your smart grid. And so what do I mean by smart grid? That is the infrastructure that manages that power. Right? That's what we're referring to as the smart grid. So the combination of solar, wind, hydro energy with battery systems, with panels. So again, all of this different equipment has to integrate and communicate seamlessly. And MQTT ends up being that glue that brings together the communication and smart grid. One of the variations of MQTT I would like to mention is MQTT for sensor networks, or also referred to as MQTT-SN. So MQTT-SN is designed specifically for wireless sensor networks and other constrained environments where even MQTT may be too resource intensive. So the basic principles of the MQTT protocol are retained, but MQTT-SN adds some optimization on top of that, based on the need to monitor sensors and devices that may be battery operated. And so how do we create more efficiency, longer battery life for monitoring equipment that's battery powered? And that's very common in this type of infrastructure where we have clean energy being produced, but that energy has to be stored, right? And then a lot of times that's in a battery, right? And in an infrastructure that has battery operated devices. So with that, MQTT for sensor networks, I want to talk about a few of the differences and advantages. So with MQTT, it does use a smaller header size compared to standard MQTT, and this creates that efficiency of less bandwidth, right? Less data being sent with each message. Also, MQTT is typically associated with TCP/IP networks, where MQTT-SN it's designed to work over non-TCP IP networks also, including UDP, ZigBee, and other common transport protocols in sensor networks. So this makes it very adaptable to different environments and provide a wider range of communication options when it comes to remotely monitoring a grid, right, and making that grid a smart grid. And then the last, and this isn't a comprehensive list, but some of the highlights in that MQTT-SN supports a sleep mode also. So for those devices that are battery powered, in order to conserve energy, they need to go to sleep and wake up and send messages and go back to sleep. With MQTT-SN, it makes it a lot easier to manage those devices. And again, with MQTT and our broker, one advantage that you'll get is being able to reliably move your data into the cloud. And as you can imagine, these types of infrastructure, these types of workflow are very much tied to cloud services. So MQTT and MQTT-SN can help you bridge that gap between your sensors in the field and your data in your local cloud, data center, or private cloud. The second example I want to talk about is a very popular one that we've seen this year, and that's why this one made the list. We've been working very closely with the automotive manufacturing industry this year, and it really reflects. It shows in our feature set. It shows in our roadmap. Our dedication to solving some of the issues that they're facing with electric vehicle connectivity, communication between not just the electric vehicle itself, but the electric vehicle and the cloud, the electric vehicle and charging stations, and even electric vehicle to infrastructure. Or so all of those options MQTT can help with. And one of the advantages is that bi-directional communication. So with the connected vehicle, they can send, the vehicle itself can send telemetry data in real time, right? To collect that data, filter that data, and deliver it to the cloud or your infrastructure. So to enable remote monitoring, predictive maintenance, start to catch problems early and proactively. So the again, one of the keys um, that enable this is that single digit millisecond latency, right? We're talking very low latency. Even when we start to scale up to millions of messages, and as Brandon mentioned, most enterprises are not at that level yet, where they are connecting millions of devices. But it gives you good confidence to know that even when you need to scale to 1 million devices, we can already support that, and we're just growing. And so the the benefits of with the benefits of MQTT and our dedication to the development of our broker, we've had some pretty good success in the industry that I want to share with you. So, five out of the 10 largest automobile companies use our technology. 7 out of 10 electric vehicle startups use our technology. We're trusted by over 50 automobile companies in total, and that's not just in the cars themselves, but we're starting to see more examples of needing to monitor and integrate our systems into the factory itself. So even as the car is being built, you still have that real-time monitoring, the low latency, the view of your devices on the manufacturing floor. And so that automotive life cycle continues with from manufacturing to monitoring the vehicle itself to actually monitoring the charging infrastructure. And so it all ties in, and by integrating and consolidating that information, it gives you some great advantages. And that's why you see us used in over 100 car models and over 10 million EVs and cars on the road today access our technology in one way or another. And so I'm very we actually too have a couple of webinars that we've done this year that talk about connected vehicles and how MQTT is paving that road for communication with electric vehicles and charging infrastructure. So make sure you go to our website and check out some of our previous webinars also. You'll find some good information there. So I mentioned earlier the importance of data in the cloud, right? And so it's not just about the communication between devices, but the integration and how do we connect our sensors, our devices in the field to the cloud, and how do we do this efficiently, reliably, and timely? And so I won't get into too much of the technical details in today's webinar, but I want to give you a visual and talk some about how this works and where EMQ sits in this process. And you can see on the left here, we have a group of sensors, right? Sometimes that may be custom proprietary sensors collecting data on the manufacturing floor. That may be sensors in the vehicle itself, collecting data. That may be sensors in power lines, power equipment, or even connections from some of your other locations or data centers. And so MQTT becomes that bridge between those devices in the field and the cloud. And there are some particular advantages that we implement while we're doing that message handling and message routing. As Brandon mentioned, MQTT has a very decoupled architecture, right? So even though we may have millions of sensors of data points connected, it's a very loose mapping. Right? So every device does not need to know about all communication. So you can be very particular about how you want to handle your messaging, how you want to filter and clean your data, and that's when it becomes usable. Right? It's not about just providing terabytes of data. It's about providing efficient data. It's about providing data that you can use. So with that message routing between connecting the remote devices to each other or to your data center, we also have a rules engine. And so what that rule engine does is help with that data filtering. And so we can, for particular devices or particular clients, we can create triggers, create alarms. We can only supply the data or messages that are relevant to a particular application or to a particular group of users. And so that message routing and that rules engine, it really provides a lot of value. And as we're moving that data from the edge into the cloud. And of course, your normal enterprise security is implemented on top of that to make sure that your data is protected. So authorization, authentications, access control list, all these things are included at an enterprise level to make sure your data is protected. And then there is, you can see on the right here, there's the integration to those backend systems. And we have a pretty active development team, and so we're constantly working on adding integrations. And so some of the ones you see here, like Kafka, MongoDB, InfluxDB, these are integrations that we have prepared you for ahead of time, right? So this allows you to implement very quickly in a very simple method. A lot of this is done through the GUI, so you can start to create those data integrations with no code. And so that's what makes this very one of the things that makes this very popular to implement is an enterprise may not have the technical talent, the developers to sit down and write code for these integrations, right? So within our dashboard, we make it very easy for someone who may not be a specialist to be able to still build this workflow and enable communication between your edge devices and the cloud. And so that's what we see at the bottom here in this bottom layer. That represents your options to deliver that data to the cloud. And you can see we support every major cloud provider. We support Alibaba Cloud. We support Microsoft Azure, AWS, of course, and Google. And so no matter what public cloud platform you prefer, or what even if you do a private cloud or a combination of clouds, which we're seeing more popular is happening more, is that diversification of cloud services, right? So you may have some processes on AWS and some on GCP, for example. But getting that data into the cloud, no matter which cloud, is extremely important in these types of workflows. So now Looks like I have about 10 minutes here, so I'll try to work through. I'll talk about four successful use cases that we had recently, and I've was involved with these customer stories, and it made me proud to see that we're enabling cutting edge technologies and creating efficiencies, providing a platform that our customers rely on and can grow with and scale confidently with over the years. So the first one I'll talk about here is China Three Gorges. So the China Three Gorges project was founded in '93, and they're a clean energy group focusing on large scale hydropower development and operation. And the this so that covers the construction, international investment, contracting, development of not just hydropower, but wind power and solar power. And so over the last 20 years or so, Three Gorges has become one of the largest hydropower development enterprises in the world. And so you can imagine they are some of the challenges we mentioned they were facing. And so some of those challenges being lack of reliability and high cost, right, to make services reliable. Also, limited management resources and for high volume, high data collection. So what do I mean by that? By these types of infrastructures have very frequent communication, right? So when you have very frequent communication from a large number of devices, it becomes difficult to manage all that communication. And so and then there's also they didn't have any real-time data analysis available. And when we say real-time, sub-second. And so with Three Gorges, by joining with EMQX and implementing our MQTT broker, we saw several advantages that address these challenges. So one thing we saw with them is a 15% increase in battery life capacity, a reduced, which also ends up introducing a reduced cost in battery replacement, more efficient energy storage. And so what I mean by more efficient energy storage is the balance of energy across several batteries. So being able to move and change processes because you have that real-time monitoring, you have that real-time view into your infrastructure. And so overall, by partnering with Three Gorges, we're able to provide more than 30% savings in operations and maintenance costs. So that's one example where MQTT in the clean energy space really provides all those advantages that we keep talking about. The next one I want to talk about is Unitron. And there's so many, there's so many different examples that we're seeing. And it's exciting to see how our customers are taking this technology and applying it in so many ways. So with Unitron, they are manufacturers of purpose-built communication equipment to monitor waste collection. So things like trash reception, trash and recycling. So Unitron has multi-purpose smart waste sensors. And these sensors can be programmed to monitor weight, the fill level of the container itself. It can alarm, let's say when it's time for a pickup, or and give that overall view of that waste process, right? And if you think about the difference on where we were today, and it seems something simple like waste collection, right? But think about how many like say a garbage truck, right? How many stops does it have to make per day? How many
Mhm.
of those waste containers are have to be collected, monitored? Did we miss a stop? How efficient were we on our route?
Yeah.
Is there a more efficient route? So all these things allow us to make some leaps ahead. And one of the advantages that we created there was we were able by partnering with Unitron, we were able to be the glue again. And so, as you could imagine, all of these different sensors that monitor these different levels for the waste containers, they have to their communication needs to be consolidated, and it needs to be brought into the cloud, right, where you can use it, where you can filter it, where you can take some action. And so Unitron was an interesting example and a different example on how we can help to implement some cutting edge technology. And another that I want to cover, and this one was exciting for me too, and just seeing the advantages and the benefits when you're able to implement a smart grid. So we talked about smart grids earlier. RavenVolt is a producer of those smart grids or micro grids. So they provide the ability to remotely monitor grids, power grids. Most of this for them, their concentration is mainly around electric vehicle charging and monitoring those microgrids that support EV charging. And one of the advantages of being able to monitor those systems in real time is, for one example, is recovery and prevention of loss in power during a hurricane. So with RavenVolt system, not only are they bringing in all the data from the sensors and from that power grid remotely, it's also tied into the weather system. So in real time, you can see if there's adverse weather conditions that may affect the power generation of in certain places, right? So as you can imagine, that we said earlier that this sustainable energy is very much dependent on weather conditions, especially solar, right? Solar and wind. So it's important to be able to tie all that data in, and uh, make actionable repairs, maintenance, and proactive. Be more proactive about monitoring your solution. And so with RavenVolt, where we help there is we collect all that data from each of the microgrids or charging station grids, and we collect all the messages for that locally. We filter that and send it back to their data center about every 5 seconds. And the last one I'll cover here before we get into Q&A, and you still have some time today. If you do have any questions, you can post that in our Q&A chat. We'll get to as many as we can today. And if we have some questions we don't get to, we will follow up with email. So before we start that, one more. One more successful customer case story we've had this year in the clean energy sector is EV Power. So EV Power needed to solve the problem of advancing EV charging, making it again more reliable. They needed to be able to process 30,000 data points per second, 30,000 data points per second concurrently. which ends up being about 30 million data points per day.
Mhm.
So some of those data points include network status, charging, real-time logging, site power usage records, and even billing, and to be able to process and analyze billing in real time. And so we're very happy, very proud to be part of all of these cutting edge technologies, and we're interested too to see what projects you have out there, to see what cutting edge solution we'll see implemented next with our technology. So that being said, that takes us to our Q&A section. So Brandon, I'll read some of the questions that
Yeah.
we have in chat here, and you can jump in
Mhm.
if you would like to answer it, and we'll bounce them back and forth. How that sound?
Sounds great.
Okay. First question we have here: is this a greenfield or brownfield technology? Well, this first, I'll say that let me say what a greenfield or brownfield technology is. So, by greenfield, does this require a new implementation? So, or brownfield, can this be retrofitted into existing technology? Our EMQX broker, MQTT protocol is a brownfield technology. So that allows you to bring legacy products, legacy sensors into the future, right? So
Mhm.
create these smart technologies. One example would be one of our customers, Alpha Ori, that retrofits cargo ships. And so these aren't new ships. These are ships that have been in service for quite some time, but we're providing that value now of being able to monitor all their systems, to be able to make real-time decisions based on weather, based on data conditions that are coming in, based on alarms. So it's definitely a brownfield technology. So if you're trying to implement something existing, or you're trying to kick off a new technology, MQTT is still a great protocol to be that glue. Hopefully that answers that
Yeah.
question. Next one: what advantage does MQTT offer in terms of scalability when expanding clean energy networks?
I'll jump in there, Ernest. I did see this question come in earlier, so I'm sure that we answered it along the way. But just to recap, right? This is a very important space. As we know, it is growing rapidly. Going back to at least MQTT through EMQ, um, being able to support those large deployments up to 100 million concurrent connections, right? So there is already ample headroom to be able to hopefully support devices for the foreseeable future as we continue to draw that line forward. But uh, it really goes back to the decoupling of the connectivity between devices. So you're freeing up that bandwidth that would otherwise be consumed by traditional IoT applications using different protocols. So by doing that, you'll be able to transmit bidirectionally up to 1 million messages per second, with, as Ernest mentioned earlier, with that sub-millisecond latency. So as close as to real time as you can get to today with today's standards.
Thanks, Brandon.
Of course.
Next question we have here is a roadmap question. Could you talk about some of the new and upcoming features for EMQX? I can get us started with that one, Brandon, and
Yeah.
if you want to supplement that.
Mhm.
Uh, some of the features that I'm excited about recently is definitely, and I should have mentioned this, a great question, is our implementation of MQTT over Quick, QUIC. And so Quick is a communication protocol that sits on top of UDP. And MQTT traditionally works over TCP/IP networks. So we that was a change, and we are the first MQTT broker to provide support for MQTT over Quick. And when we talk about connected cars, especially going through different networks, going through different cell towers as they travel, that combination and the reliability of MQTT and the reliability of Quick being able to switch networks quickly and reliably, those two uh, have provided some great advantages, especially in the automotive industry. So that's something I've talked to a lot of our customers about this year. The one of the other recent features I would say, or I wouldn't say a product more than a feature, is our Edge Cloud platform. And so recently we introduced what we call our Edge Cloud platform. And what that does is it provides some edge management capabilities with Neuron, eKuiper, with our broker, with the MQX broker. And so this creates a easier to manage infrastructure from your edge devices all the way to our broker. We introduced some remote monitoring and configuration capabilities to Neuron, and it just gives you. We've saw that popular with our recent customers that want to take away that layer of management of making sure that their edge devices can reliably communicate. If we can take that part of it away from all the other things they have to manage, we're both winning. Anything? Well, those are some that have been implemented. Anything interesting coming up, Brendan, that you want to mention?
Yeah, one that I think will be of interest, especially tying back to your example for EV charging stations that is currently in the works and that we're excited about, is having that official support for things like Open Charge Point Protocol, so OCPP. So that will really streamline the process in connecting and translating those devices to get them running more efficiently. Not to say they weren't before, but this is just driving that that line even further. And another one was, I guess, when dealing with the different backend integration processes, right? We do now have a drag and drop interface to make that process more seamless and much more efficient, right? So instead of using services like Node-RED, you now have a drag and drop place within our own dashboards where you can tap into things like Kafka, different databases of your choosing. And I guess another integration that we are excited about was with Confluent. So the same manufacturers or the same developers of Kafka rolled out this new association or grouping, if you will, called Confluent. So recently became a certified partner. And going back to what Ernest had said about Quick, right? We were the first company to do so, to integrate Quick, a replacement for TCP by Google. And it was something that was, because we were pioneering and the first mover in that space, we even got recognized by Frost and Sullivan for that particular innovation. So really do encourage you to take a look for more information. All the case studies that Ernest covered, the announcements that were mentioned, there is a lot of detail on those topics on our website.
Thank you, Brandon. And you proactively answered one of our other questions. I don't know if you saw this one, but it says I see that you have an integration with Kafka. Could you talk about how that integration works? And so you covered that in that we do have what we call our flows. So we have a visual interface where you can drag and drop these components and be able to enter connection information, port, IP address, though that relevant information to be able to connect, authenticate, and bring data into and out of those systems. And so we're continuing when we talk about our roadmap and our recent features.
Yeah.
That's something that we continue to make sure we provide an investment in is those integrations. And
Yeah.
you can check some of those out at emqx.io/integrations. And so you can see some of the integrations that we already have there that allow you to connect to your services quickly.
Yeah.
And looks like we covered up. We have one more here. How does MQTT support predictive maintenance?
I'll jump in there too, Ernest. You can add on if I miss anything, but I know we touched on this quite a bit throughout, but right, just to, I guess, revisit its significance and how it contributes to this. I would say that MQTT really enhances predictive maintenance, right? And why is that? I would say it's because of that real-time transmission. So if yes, you can go ahead and provide predictive maintenance with near real time, but what we're doing with this protocol is we're closing that gap for there to be issues, right? So if let's say an event can happen within 2 minutes, you don't want to wait 2 minutes to see that, there's a red alarm and there's a fire that started. We're cutting that and reducing it to sub-milliseconds. So you have quicker response times to be able to get in there and to be also set thresholds to detect when an imminent failure is going to occur. So you can really get in there, reduce downtime, improve uptime as a result. And ultimately you're cutting back on support costs and just having a more streamlined, efficient system.
Thanks, Brandon. So we are approaching our time restraint here. So let me wrap up with saying, for one, thanks everybody that registered, everyone that attended. This will be available on demand if you missed it or missed some of it. You can left this slide up for you, so you can see our contact information, contact at emqx.io for general inquiries. You can contact our sales, our support. We are engaged in many partnership discussions because of the versatility and power that MQTT provides. So happy to be. We covered clean energy today and wrapped up some of the customers there, but we really spread out across many industries, and so it's fun to be involved in again in such an enabling technology. All right, thank you all for joining us, and we'll see you next time.
Yeah, thank you everybody. Happy holidays and happy new year.
Thanks.
Thanks.